Let's consider this program here. Look at the first line. It's saying number is assigned input, and then there's a user-friendly string saying please enter a number. Now when this program runs, that string will appear and it's requesting that the user enters a number. Now let's just say, for argument's sake, they enter 21. So if we come to this line, it would appear that what's happening is this 21 that's stored in number is being multiplied by 2 to give us 42. And that 42 is assigned to double number, and of course then we print out what's stored in double number, so we should have 42 appearing on the screen, or that's what it would appear to be the case just by looking at this program here. So let's just see what actually happens. So we can see that we have this user-friendly string appearing, please enter a number. The user then enters the 21. We come onto this line here, that executes, and then we execute this line, and it will print what is actually being calculated by this program. And we can see it certainly isn't 42. In fact, it's 21 and 21. Or if you want to think of it, you could say, well, isn't this 2121? Well, in fact, no, that's not what it's actually representing. Because what we've done on this line here, we've entered a string. So number becomes a variable that's of type string. And we've entered a 2 and a 1 in it. And what this line is doing, it's giving us 2 lots of that particular string and assigning it to double number. And double number is in fact a string. So what we end up printing here is the content of the string double number, which is 2121. Let's look at this in a little bit more detail. You see, when this line executes and we enter the 21, we create a string. Now a string is just essentially a sequence of characters. So we have the 2 that was entered by the user and the 1 entered by the user. Consequently, what we're actually doing on this line is taking the string 21, and you can see I've put these 2 quotes here to emphasize that it's a string, and we're multiplying it by 2. Now this operator, we've seen earlier in the playlist, does a multiplication, but what it actually gives us in this particular case, in this context, it's asking for 2 lots of the string. So it will give 2121, which are 2 lots of the string 21. Consequently, double number will look like this. It'll be 2121. Let's emphasize this point by altering the program slightly, and you can see the alteration has occurred here where I've changed the 2 to a 3. If we now run the program again, and this time I'll enter 21, the same as I did last time, what we're going to get out is 212121. In other words, we've got 3 lots of the string we actually entered. So when the program ran and I entered the 21, it generated the string variable number, into which were the 2 characters of that string, the 2 and the 1, which really meant that I have this string 21 and I'm asking for 3 lots of it, because this, in this particular context, is asking for 3 lots of the string. So that doesn't act as a multiplication of numbers. It's saying, right, I'll have 3 lots of this particular string, please. And consequently, it gives this value here. So we end up with the variable double number now being 212121. I think I'd like to be a little bit more accurate with what I've said here. Here we can see that we are entering 21 and we have this operator here followed by the 3. Now what I'm saying is we get 3 lots of the 21 to end up with 212121. We don't end up with 3 string variables, we just have this 21 repeated 3 times, and we store it in this variable here, which is a string variable. So we end up with 1 string variable called double number from this particular process here. So overall, this program has actually been dealing with a string variable number and a string variable double number. But the double number has been created by us joining together the contents of what's in number 3 times. To emphasize that we're dealing with strings, I've actually produced this program which has just added these 2 lines to the one we've just been looking at. And if we have a look at this line, what that's doing, it's printing the length of the string variable number. That's what this len means here. And if we come down, we've got len, and in brackets we've got double number. So this will print the length of the string variable double number. So let's run this program. Here we can see the user-friendly string appearing. I actually type 21. And of course, when I press enter, the 21 goes into the number variable, as we can see here. The 2 and the 1 goes into the string variable number. Now if I go to the next line, which is double number is assigned number times 3, well, in fact that is an operator which is asking me for 3 lots of the number. I keep on using the words times, which in a sense it is, because you're timesing how many times you want this particular string repeating. We're actually saying, well, let's take the 21, multiply it by 3, so it'll give this particular number here. Consequently, we have double number being this, as we've already seen. Now, of course, we'll come onto this line and we'll print what that looks like, and we can see it's here. Now, this particular line will actually tell us the length of number, and we can see it's 2. And that's because if we look at the variable, we've got 2 characters in it. In the string, there's 2 characters, so that's said to have a length of 2. We now go on to this line, and that one, as we can see, prints 6. Now that's because if we have a look at the string variable double number, it's got 1, 2, 3, 4, 5, 6 characters. So we get the output of 6. So this again shows us that we've actually been dealing with strings here. Let's have a look at this program. It's more or less the same as the first program we saw in this video, but you can see I've had this additional word put in here, int. Now what this is capable of doing is taking what is input using this here and converting it from the string that's input to an integer. And to be consistent with what we've done earlier, I'm going to enter 21. So when this program executes, we will have this please enter a number appearing here because of this, and of course I'm now going to enter 21. So this takes that 21 as a string, this converts it to an integer, and then assigns that integer to number. So number here now is an integer variable, not a string variable. That 2 and the 1 are now not characters in a string. It is actually 21, the quantity 21 if you like, a definite integer. Now what we're going to do, we're going to execute 21 times 2, because in this context it is multiplying, it is doing mathematics. It's multiplying 21 by 2, and of course that gives 42. And the result is, as we can see from this line, assigned to double number. So double number now has 42. So when we now go to here and print the content of double number, we can see we get 42. Let's have a look at the same program again, and let's have a look at another runtime. Well, it asks me to please enter a number, and what I'm going to do, I'm going to enter 1.5. Now 1.5 is clearly not an integer. It's got a fractional bit to start with, and the program has been designed to convert the input to an integer. And of course, as I've just said, it's not an integer, so the program will actually crash. This red text appears, and it kind of gives you a hint as to what it is. If you read it clearly, the last line of red says invalid literal for int with base 10, and it puts 1.5 in quotes. In other words, it's saying, look, I can't convert 1.5 to an integer. The way to correct this, if you wish to enter non-integers, i.e. real numbers as they're called in mathematics, is you would do this. You would use the word float. Now when I run the program, I enter 1.5. So what will now happen, it will take the 1.5, multiply it by 2, as you can see from the second line in the program, and it'll then print out this, and it prints it out as 3.0. Now notice it prints 3.0. Now the fact that there's a point followed by a 0, it's definitely 3, but it's telling us that this particular output is a float because it's put a 0 there. Now 1.5 times 2 is 3, but it has made it a float because we had number being a float, and I multiplied that float, which contained 1.5 by 2, it generates 3, but it generates the 3 as a float, not as an integer, even though 3 is an integer in mathematics. In Python, it says, no, number was a float, I've multiplied that by 2, I'm giving you the result 3, but I'm actually going to store that in a variable of type float. So in this particular program, we can see that number and double number will both be of type float. We now can get to look at the eval function, which is what this particular video is really about. So if we now have a look at the program we've just been using, and we had in this position the word int, and in this position the word float, and you can see I've replaced those by the word eval. So when I run this program now, let's have a go. Here we go. Please enter a number. I'll enter 9. Now 9 is clearly an integer. So what will happen on the second line, it takes the 9, it multiplies by 2, gets 18, and assigns that 18 to double number, and then the program will print out double number. And then it does, it prints out 18. But look carefully at the 18, you can see there's nothing following the 8. There's no point, there's no 0. And that's because what eval has done, it says, right, you've entered 9, which is an integer, so I'm going to convert you to an integer type and assign you to number. So number becomes an integer variable. The second line is taking number, which is an integer variable containing 9, multiplies it by 2, gets the result of 9, and assigns that to double number. So double number becomes an integer type because it's receiving an integer. And then, of course, we print double number and we get the 18, as you've seen. If I now run the program again, but on this occasion I'm going to enter 1.5, what the eval now does, it says, right, well, you're entering a float, so I'm going to convert you to a float. So it assigns to number 1.5 and makes, or Python makes, number a float. So the second line takes number, which is now storing 1.5, which is a float, multiplies it by 2 and produces the result 3. Now 3 in mathematics we know is an integer, but because we're now in Python and talking about types, what will happen, it will produce 3 in a float format, assign that to double number, and double number will now take up the type of a float. And then when we print it, we get 3.0, and you can clearly see the 0.0 is there telling us that it is actually a float. So what eval will do, it will take in an integer, convert it to an integer, it'll take in a float and convert it to a float. Now when I say take in an integer, it takes in the string of 9, converts that string to an integer, it takes in the string of 1.5 and converts that string to a float. Let's have a look at the eval function in a different context. Here you can see it says result is assigned eval, and in brackets there's a string, and the string is 1 plus 2 plus 3 plus 4 plus 5 plus 6. Now if we map that against this particular diagram, which we've done in a few places in this particular playlist, we can see that this string is used as the input to the function and the output is given to result. Let's write a small program to show what in fact is happening here. If we look at the first line, we can see it's the one we've just been seeing, result equals eval, and in brackets we have the string, and the last line is simply printing out the result, i.e. what's worked out on the first line. And when we run it, we can see we get 21. So what eval has done, it's taken in that string of the 1 plus 2 plus 3 plus 4 plus 5 plus 6 and worked out that it's 21. Assigned the 21 to result, and of course print result is simply displayed the 21 as we can see here. Now here you can see there's a slight amendment to the program above. We now have a string which is 1.0 plus 2.0 all the way up to plus 6.0. Now of course 1.0 and 2.0 are floats. That's how we represent a float. We put some fractional bits in, and in this case there is no actual fraction. We represent that by a 0. But the point is, what we now have is a float string here, because I say that because when we run it, what will actually be output is 21.0, and we can see the 0.0 is telling us that this is actually a float. Let's now consider the following. Here we can see the program saying calculation is equal to input, please enter your calculation. The next line is saying result is the evaluation of that calculation, and the third line is saying the result of your entered calculation is, and at the end of that it will actually put the result. So when we actually run this particular program, we get the user-friendly message saying please enter the calculation. So the user enters 1 plus 2 plus 3 all the way up to plus 6, as you can see, and it says the result of your entered calculation is 21. So it displays the result with that user-friendly message. If I run it again with this same program and it says please enter the calculation, and now I enter this, which is 2 times, and in brackets I've got 1 plus 3.5. Now obviously the contents of those brackets is 1 plus 3.5, which is 4.5. 4.5 then multiplied by the 2 is 9. But the thing is, because I've got 3.5 in there, which is a float, the result is going to be a float. So what I think is going to be output in a moment is 9.0, informing us that it's actually a float. So let's have a look. The result of your entered calculation is 9.0. So here we can see we've got a way of writing a small program where the user enters a string, which would be a string of some kind of calculation, and Python tells you what the answer is. Let's consider the second line of this particular program in isolation. Here it is. Result is eval and in brackets calculation. Now what we can see is that this is a built-in function within Python. This here is a string, and we've just seen that the result can be of type integer or of float, depending upon what we actually input as a string. Let's consider the following program. The first line is simply sending a user-friendly message to the user, asking them to type in a function for y. Now in mathematical terms, a function is something like y equals 2x plus 4. And that's the example I'm going to use in this particular program here when I run it in a moment. If we look at the rest of the program, we can see that we have a for loop. And the for loop is dictated to by this range function here. And what I mean by dictated to, it means that you will go into the loop when x has the value of 0. You will go into the loop again, and the next time you go into the loop, the value of x will be 10, because this here means step up in 10. The next time you go into the loop, x will be 20, because we're going up in steps of 10. Then we won't go any further, because this says go up to but not include 30, and obviously 20 plus this 10 is 30, but we don't have x taking up that value. Now if you're not quite sure about what this range function does, I strongly advise you go back to look at the video earlier in the playlist on the range function. And of course every time we go into the loop, we execute this line here. Let's now consider the execution of this program. The first line to execute is this one here, and we can see it puts this user-friendly prompt here. Now we need to enter an appropriate function, and I'm going to enter 2x plus 4. Now to do that I have to write it, as you can see here, 2 times x plus 4. Once I press enter, this will become a string that's stored here in calculation. We now entered the 4, and on this entry x will be set to 0. So when we come here to do this calculation, evaluate the string, if we look here, this will be 2 times x, which is 0, and 2 times 0 is 0, and to that we add 4, so we get y is equal to 4. So when we print out, this will print out 4x equals, then it'll print out what x equals, which we know is 0, and then it'll print this string out, and then of course it'll print out this here, which we can see has just been calculated to be 4. So we get x equals 0 and y equals 4. Of course we now go and execute this again, but on this occasion x will be 10, because we're stepping up in 10. So when we evaluate the calculation here, this x is going to be 10, and 2 times 10 is obviously 20, plus the 4 is 24. So we can see we get x being 10, y being 24. We then go into the loop again, but on this occasion x will be 20. So when we do the eval here, of course we can see that this x is now 20, and 2 times 20 is obviously 40. We add the 4 to it and we get 44. So what this line will now print out is, for x equals 20, y equals 44. And if you have a look at what we have here, we have the points that we could plot on a graph. And when you did that, you would see that it was a straight line graph. But you've seen another use of evaluate here. You can see it's used actually inside a print statement, which means that you can pass it a string and it will evaluate it. And it returns that value that it's calculated to this position in the print, and consequently will be output as you've seen here, here and here every time you went round the for loop. Finally, this tutorial has not had a deep look at the eval function. There are other features and parameters that can be passed to this function. This can wait until later in the playlist when you have gained more experience of Python. Just a word of warning, the eval function can be dangerous if you do not know what you're doing. So in the meantime, just use it for simple examples such as the ones shown in this video. If you cannot trust the source of the string entered to the eval function, then it could, for example, under certain conditions, allow system calls that delete your directory. Check out the supporting website for these videos, and also consider subscribing to the YouTube channel and get an automatic update every time I upload a new video. Also consider subscribing to the Google Plus circle that relates to these videos.